So here's the trick. Like I said, you don't look at this as a parallelogram. Look at it as two triangles. Because if these sides are parallel, so there are two parallel sides, that means that if I have a right angle here, I have a right angle here, right? And if I have a right angle here, that means this triangle in green, that is green, believe it or not.
No, you can tell it's green.
Good. So that triangle in green, that has an area of half base height. How's that? Sweet. So if the area is half base height, please. There's my cursor. That's going to be half 8 times 6. And that therefore works out to be 4. That's 24. Is that right?
Turn it on your side like this.
So, if that's the case, then the overall area for the whole thing is...
6 was the height.
I know
6
6?
is the height. 6 is the diagonal. Now if you turn it on the side.
Okay, here, let me make a small change here then to accommodate that question. All right, let me do that. Let me write it this way. So instead of writing it at 8, 6, let me write it as 6 times 8. And I'm going to take this triangle that's right here, pull it out, and flip it up. So it looks like this. Here's 6. Here's 8. Here's x. Here's 10. I'm just going to pull it right out of there and rotate it up. Boom! And now I can find the area of that triangle.
Wait, you took the little triangle.
Yeah. No, I took the whole green triangle. Here's the 8 from right here. Is now right here.
Oh, that's a right angle up there.
And then here's the 6. And it's right here. We are solving for x. You're like, wait a minute, where are we going to get x? Okay. These two triangles are the same. So they have the same area, right? So if they have the same area, that means that I can go ahead and say, well, area of a triangle is half base height. That means that the area of 24 is going to equal half base 10 times x. Divide both sides by 5. Okay, multiply both sides by 2 and divide by 10. And that gives you 4.8.
Too much work.
Now, the thing that makes this problem challenging is that it's not a find the area problem. It's not a here's the area, work it backwards problem. It's a problem where you have to find the area and work it backwards at the same time. It's a two-stepper. And the challenge comes in that you have to look at it not from the standpoint of, ooh, shoot, we didn't do a lot of these in practice, I don't know what to do, but in the sense of, hey, what can I find? Let's find some stuff. Okay, that's not useful. Let's find something else. And you can't keep trying things out until you work your way into something you can use to get the solution. You could also do it this way. Once I know that the area of my green triangle was 24. So once I have this, let's look at the whole parallelogram for a second. So we'll look at the whole parallelogram. That's this whole area. What's that area of the whole parallelogram? 48, because it's two of those triangles, right? Exactly. Once you have the whole area is 48, you say, oh, well, I know the area of a parallelogram is base times height. So that means 48 must be x times 10. X is 4.8. Ooh, okay. Why did you not use the Pythagorean theorem to find x? The problem with the Pythagorean theorem here is, yeah, we don't know where this point hits on the 10. I don't know if this breaks it into pieces that are like 4 and 6, Is it 5 and 5? Is it 3 and 7? I don't know any of those. So my strategy is find the area I can find, which is this triangle. I've taken it and twisted it so it's up on its edge. So here's the 6, here's the 8, here's the 10. Do that, get that area here, and then use that to either find x by working with the area of that triangle, or say, hey, here's the area of the whole parallelogram, which is 2 of those triangles glued together, and then work that backwards to get the height. If they don't give you the diagonal, they just give you the 6 and the 10, you can't answer it. On the study guide? The quiz. When we go over the quiz, we'll take a look at that one.